Okay, hello everyone. I welcomes to all in our lecture series on Dirac delta function. In this lecture series, we are discussing these topics, which are most essential for B.sc, B.Tech, M.sc, M.Tech, and various entrance examinations. In our last four classes, we discussed introduction part of Dirac delta function, representation of Dirac delta function, properties of Dirac delta function. Up to seventh property and corresponding numerical we discussed. In this class, we are going to discuss eighth property and corresponding numerical. Okay, so let us start. These things we have been discussed in our last four classes: representation of Dirac delta function, application properties. Here up to this much properties, up to seventh property, uh, in detail. This one last class we discussed seventh property, and we discussed its proof and corresponding numerical. Okay, today class we are going to discuss eighth property. Then we are going to go for the numerical based upon this eighth property. Okay, here eighth property tells that del x square minus a square equal to 1 by 2a mod del x minus a plus del x plus a. This is one of the important property. If this question will ask in your exam, it will ask for 6 mark itself. I have been detailed derived this property. Carefully watch and prepare for your exam. To prove the above property, let us consider a continuous function f(x). Multiply this continuous function with both sides of the above equation and integrate both sides from minus to plus infinity with respect to x. This is the equation. I have to integrate with respect to x and limit is your minus to plus infinity, right? And we got equation number 1. Consider LHS of equation number 1, this one, right? Here I segregate the limit. Here it was minus to plus infinity. I segregate like this: minus to 0, minus infinity to 0, then 0 to infinity. Okay, now put t equal to x square minus a square. Dt will be 2x dx, because a square is a constant, the derivative will be 0. Dx will be dt by 2x. Okay, here you can see we consider t equal to x square minus a square. Hence x will be plus or minus root over of t plus a square. So instead of x, I substituted plus or minus root over of t plus a square. Okay, now we are going to check the new limits. Here you can see, if I'll substitute x value plus or minus infinite, here if I'll substitute plus or minus infinite, t will be infinite because it is square. Plus infinite minus infinite always will be plus infinite, and subtracted with by a small number, so it will be always plus infinity. Now consider x equal to 0. If I will put x equal to 0 over here, then t value will be a square, right? So the new limits are infinite for plus or minus infinite. Instead of x equal to plus or minus infinite, we have to put t equal to infinite and t equal to minus a square instead of 0. Same thing we have been written here. And after also we have to substitute these values. So the integration limits will be here: minus infinite means plus infinite, 0 means minus a square, plus infinite to a square. Okay, x value is how much? Plus or minus root over of t plus a square. Here I written minus t plus a square root over. Okay, why it is? Here you can see this f(x) or this integral is in the range of minus infinity to 0. So here minus infinity to 0, this integral values we are going to consider, and this integral or this function exists 0 to plus infinity. Okay, so obviously here for this limit, or for this range, this x will be the minus x and this x will be the plus x. Got it? So only for that, here we have x value, we have two x values, one is your negative and another is your positive. So in this range x will be negative, hence we written minus root over of t plus a square into delta t, because t we consider as x square minus a square, and dx, here dx will be also negative, negative dt by 2 into root over of t plus a square, whatever I written over here. Got it? Okay. But in this range, after 0 to infinite, it is positive. All the values, x values are positive. Only for that we consider, for this one, for this integral having the limit 0 to infinity, x considered as positive value, that is your positive t plus a square root over whatever I have been written delta t, and obviously dx will be positive itself, plus dt by 2 root over of t plus a square. Okay. Okay, we are going to move for the next step. Okay, same thing I have been written. Okay, same step. Next step, here you can see I just written in this way. This term I just divided with this one. That's it. And this term I just divided with this one. So what we found, and another thing I also done over here. Here minus sign is there. When the minus sign will be interacted with this integral or integration, the limits will be exchanged. Upper limit will be lower, lower limit will be upper limit will be lower. So here minus sign interacted or omitted, you can see, and the limits are exchanged. Here infinite to minus a square, now it will minus a square to infinite f of minus root over of t plus a square by this term 2 into root over of t plus a square delta t dt, right? Right. And here uh, this value as such I written by this value 2 into root over of t plus a square delta t dt. Okay. Okay, now we are going to apply the fourth property of this Dirac delta function on this integral and this integral. According to fourth property, what we know? We know minus infinity to plus infinity fx delta x minus a dx equal to f of a. Here delta function exists for this case, for this integral delta function exists. This is your x equal to 0 and x equal to a. Delta function exists at x is equal to a, and the continuous function fx interacted with the delta function, we can get this result. Okay, you just consider this integral carefully. In this integral, here delta t is written, or we can write delta t minus 0. That means this delta function, for this case, for this integral, delta function exists at t equal to 0. So this is your t axis, and t equal to 0, the delta function exists. Here the delta function exists, and the function here the so-called f of t, this one, the whole function. Okay, and this function exists in between minus a square, this is most important, minus a square to infinite. Minus a square means somewhere here, this is suppose minus a square value, and upper limit is your infinite. Okay, that means the function will be interact this delta function in this range. There is no other way, it will interact and it will give the value. So what will the value by using delta function? Here you can see, here the so-called a is your 0, so the value will be f of, carefully you just observe here, this is your delta t minus 0, so this will be f of minus root over of 0 plus a square by 2 root over of 0 plus a square, or we can found here f of root over of a square is nothing but a minus a by 2 root over of a is your a, root over of a square is your a. This much value we can found whatever I written here by using fourth property. Here I not written, at the time of uploading this note I'll write by using fourth property. By using fourth property, we can get this one from this integral. Likewise, from this integral, we can get this value f of a by 2a, right. So that implies, here you can see this value we found by solving this one. Here you can see we considered actually this value LHS of this one, and we solved and we found what, this value. Let this is your equation number 2. Now consider RHS of equation number 1. We considered the LHS. Now we are going to consider the RHS of equation number 1. The RHS of equation number 1 is your this one. See, here it is written in the bracket. So if I open the bracket, I can get two integrals. So I written here by considering RHS of equation number 1. Here mod is there. Mod means the a value may be positive, may be negative. We are going to consider two values. Here for case 1, we consider for a greater than 0. Case 1 we consider a greater than 0. Case 2 we are going to consider a less than 0. First you just consider a greater than 0 means a value is your positive, right? A value is your positive. So if it is so, here you can see 1 by, I have to write plus a not written, plus a, and its mod minus infinity to plus infinity was there, fx delta x plus a means it will be minus a dx plus 1 by 2 plus a mod minus infinity to plus infinity is there, fx delta x, here a is the positive, so automatically it will be plus, it will be there x plus a dx. Okay. Now 1 by 2a mod minus infinity to plus infinity. See, if this is your positive, so it will be 1 by a, 1 by 2a. So no need to write mod. I have to correct it. Wait. So 1 by 2a mod will be 1 by 2a, and the integration same here also written. 2a mod will be 2a, and the integral, the above integral written as such. Now you just apply the fourth property on this integral. This value will be f of a, and this value will be f of minus a. Why? This is delta x plus a is nothing but delta x minus of minus a, right? So here this value will be f of minus a, this value will be f of a according to fourth property. 1 by 2a is the common factor for both the integrals. So we found 1 by 2a f of a plus f of minus a, or we can write minus integration to plus integration here from this integral by considering RHS of equation number 1. RHS of equation number 1 what? This one. So this value is this value. This value is nothing but we found what? 1 by 2a f of a plus f of minus a. Let this is your equation number 3. Now we are going to go for our case 2 for a less than 0. That means if a will be negative. If a will be negative, the RHS of equation number 1 will be, the RHS of equation number 1 is this one. We have to substitute instead of a with minus a. Here a we have to write minus a. If I will write minus a over here, it will be plus. If I write minus a, it will be minus. Same thing I have been written over there. 1 by 2 mod of 2 minus a minus infinity to plus infinity fx delta. See, in your equation number 1 it was delta x minus a. If I am going to substitute minus a, so obviously it will be x plus a. Same thing I have been written, plus 1 by 2 minus a mod minus infinity to plus infinity fx. Initially it was delta x plus a, now it will be x minus a dx, right? Minus a mod is your plus a, so it will be 1 by 2a, and this integral as such I have been written over here. Here 1 by 2 minus a mod will be 2a, and this integral as such I have been written over here. Now I am going to apply the fourth property on this integral and this integral. According to fourth property, what we know? Fx delta x minus a dx integration minus infinity to plus infinity equal to f of a, right? Here you can see delta x plus a is there, so it is written as x minus of a. So for this integral, this value will be f of minus a, okay, f of minus a, and for this integral it will be f of a. 1 by 2a is common for both the integrals. So finally we can get 1 by 2a f of minus a plus f of a. So that implies RHS of equation number 1, that means this one. Okay, this one will be equal to this much, right? Here I written first this one and second this one. Or RHS of equation number 1 is nothing but here this one, RHS of equation number 1. So we can write this one also is equal to 1 by 2a f of a plus f of minus a. Let this is your equation number 4. Carefully you just observe here. I am comparing equation number 2, 3 and 4. This is your 4. RHS is your 1 by 2a f of a plus f of minus a. Equation number 3, same. Both equation number 3 and 4 is equal to RHS of equation number 1. This is your RHS of equation number 1, right? Now compare with equation number 2. The equation number 2 tells that the LHS of equation number 1 is equal to this much, which is the RHS of 3 and 4. Okay, that means this value equal to this much. That means LHS of equation number 1, this one, LHS of equation number 1, we found how much? This value 1 by 2a f of a plus f of minus a. And considering RHS of equation number 1, also we found this value, same value, 1 by 2a f of a plus f of minus a. Considering a is a positive and considering a is a negative, also same value. That means LHS of equation number 1 will be equal to RHS of equation number 1, hence proved. Okay, same thing I have been written over here. By comparing 2, 3, 4, this integral that will be equal to this integral. If I am going to compare both, fx is a continuous function, we can separate out. Integration same limit is there with respect to dx. If it is so, then this value should be equal to this value. That means delta x square plus a square equal to 1 by 2a delta x minus a plus delta x plus a. This eighth property is most important for your exam point of view. Here I am going to tell to you one thing, that actually this is not exactly the eighth property. That means you cannot say that this is the eighth property of the delta function like Maxwell's equation. If I am going to consider Maxwell's first equation tells that del dot E equal to rho by epsilon naught. This is the first. Second is telling that del dot B equal to 0. This is the second Maxwell equation. But here this is not called as the eighth property. Okay, here I systematically written. So after writing, so it is this property. Now the serial number is 8th, but this is not exactly the 8th property of the delta function. Okay, keep it in your mind. Now here we proved this one. Okay, one is the important thing I'm going to share with you from property 7 and 8. From property 7 and 8, property 7 what tells us? Property 7 tells us delta ax equal to 1 by a mod delta x. So property 7, here I am writing from 7th property, delta ax equal to 1 by a mod delta x. This much we found. From this property we found this one. Okay, so by considering property 8, this is your 8th property and 7th property, we can write in general as this one, delta fx. See here delta ax, this is also a function of x. Here x square minus a square, this is also a function of x. Yes or no? Yes. So in general we can write delta f of x equal to summation over I 1 by derivative of first derivative of fx summation with its roots xi, its roots delta x minus xi. Here xi represents the roots of the function fx. Okay, here I am going to show you that this also satisfy for this one and this one. Okay, first I am going to show you for this 8th property. So here we found that fx for this one, fx is what? Fx we found what? X square x square minus a square, x square minus a square we found, right? So the roots of this function, if I'm going to take roots of this function, then x square minus a square equal to 0, x equal to plus or minus a. The two roots are, one is your plus a and another is your minus a. Now consider f dash x. F dash x is your how much? 2x. Okay. Now we are going to write this one. Here you can see. Here you can see. Uh, Delta fx will be equal to, first I have to write 1 by f dash a. Here f dash a mod. So 1 by f dash is your 2x. 2x. First root I am going to consider plus a and mod, corresponding mod. Delta x minus a. X minus the root a. This is your, see, x1 is your a and x2 is your minus a over here, right? Plus 1 by 2 into minus a mod, see here summation format is there, 1 by 2 into minus a into delta x plus a. Okay. So finally what we can get here, here it is the plus a minus a mod is same, or we can write 2a mod delta x minus a plus delta x plus a, whatever we got this one here. Okay. So this expression, you just remember, it is very much essential whenever we are going to do the numericals. At that time you can found that this expression is very essential. Okay. Now likewise, seventh property also we can prove or we can verify by considering this one. Seventh property, according to seventh property, what we had, we had ax equal to 1 by a mod delta x. This was our seventh property, we already proved. And here fx is what, fx equal to ax, right? If I'm going to try to find out the root, that means ax equal to 0, x equal to 0, only one root is there, only one root, that is your x equal to 0. Now consider f dash x. F dash x is value is your what, f dash x is your a. Fx equal to ax, f dash a is your a value. Now we have to write this one here, summation over 1 by f dash means a, f dash means a, only one constant and its corresponding mod, into delta x minus the roots, here only one root, 0. Okay. So finally we can get 1 by a mod delta x, whatever the result we have been proved at that time in our previous video. So here I suggest to all of you that you just remember this expression, which is most important. So this is the most important expression. I suggest that you just remember, which is essential for doing the numericals. Okay. So here I am going to stop this lecture. In our next lecture, we are going to discuss numericals based upon 7th and 8th property. Okay. Thank you so much for watching this video. Thank you.